So let me check if we are live or not so that I can start the session. Okay, so till in the meantime you can comment in the comment section ki am I clearly visible and audible to all of you? Yes or no? Tell me fast. Okay. So, hey, hi, hello everyone. Welcome to this session of revision of ammonia and welcome to the Unacademy ICSE and ISC YouTube channel. So, can you all like hear me properly? Am I clearly audible and visible? Just let me know once. Yes or no? Okay, so this is Manisha, your class 10 chemistry educator. These are my credentials. I have more than 6 years of teaching experience. Hello Ankur, welcome to the session. Very good evening. And you can join me on Telegram for homeworks and class notes in PDF format using this link given here. And there is an official Telegram channel of Unacademy ICSE and ISC boards. The link is in the description box, which you can join by clicking the links. Okay. So the special class timing for class 10, okay, at on Unacademy app is from 4 to 5 p.m. You can join the classes at these timings for class 10. So what are the special classes? What benefits you have from special classes? You can learn live from the favorite educators for absolutely free. You can engage with educators via polls, clear your doubts in live special classes. And for top special classes, you can visit the links given in the description. Okay, so if you want to have a very serious preparations for your class 10 from very beginning of the session, you can go for Unacademy subscription and you can see there are so many benefits of the subscription, like you can learn live from the comfort of your home, unlimited access to all the courses, top educators, regular doubt solving sessions, coverage of syllabus, everything, each and everything you will get at a single platform. You do not have to go anywhere searching these things. Also, with single subscription of class 10, you get 11 and 12 subscriptions, 11 and 12 subscription for absolutely free using my code Manisha Live. ठीक है, Manisha Live is the code that you have to use to take the subscription, which will fetch you 20% discount right now. ठीक है, 20% डिस्काउंट मिल सकता है एंड सब्सक्रिप्शंस आर अवेलेबल एट अफोर्डेबल प्राइसेस फॉर डिफरेंट पीरियड्स ऑफ टाइम. You can go for any period of time, and if you are like planning for the whole year, you can go for 12-month subscription. Okay, so there is a offer ongoing. So this offer is valid up till 28th of April, where if you apply my code for taking the subscriptions, you will get 20% discount. That is, if you take the subscription for 12 months, that will be only available at 8K. Very, very affordable amount you have. So you can just go for it because this is the best opportunity, best time to take the subscription. Okay. So let's start the topic then. So we have the most awaited topic, that is your ammonia under study of compounds. Very lengthy topic, under study of compounds, one of the lengthy topics. So here we will be discussing everything about ammonia, from right from its preparations to the chemical properties, physical properties, aqueous ammonia, reducing nature of ammonia, everything we are going to discuss. Okay. So please share the link of this session with your friends as well, so that they can also get to know about this session and can attend this session live, because attending the session live gives you an edge over watching the recorded session. Yes, because here you can clear your doubts as well. So let's start your ammonia. So ammonia has a chemical formula NH3. Basically, we will start with the lab preparations of ammonia. In the lab preparation of ammonia, we use two different methods. Okay? They are preparing history. Okay, Ankur, chalo. No issues. So lab preparation of ammonia mein what we do, we take a ammonium salt. Okay? We take ammonium salt and we react it with a alkali, with an alkali, and we heat this mixture. So what happens? Your ammonia is formed, salt is formed, and water is formed. Clear? Ammonia, salt and water, these three things are formed. So in the lab preparation of ammonia mein, in the case of ammonium salt, we take your ammonium chloride, and in case of alkali we take your calcium hydroxide. and we heat these both and it produces your ammonia, your calcium chloride gas and your water molecule. Okay. Hello Balveer, welcome to the session. So I am not sure about it, Valveer, because this can be done for the new academic session students. But right now we do not have any we do not have any classes for your civics and history. Okay, so very sorry for that. Chalo, but it will be soon available in the coming future. So coming future may it will be available. So you have to wait till then. Okay. So anyone, any doubt? ठीक है. Now the questions that can be asked from this particular lab preparation: why calcium hydroxide and not some other alkali? Anyone would like to give the answer? Why calcium hydroxide and not like alkalis like sodium hydroxide and potassium hydroxide? So what is the reason for that? Yes, so the reason is that both of these alkalis are deliquescent in nature. Okay, that means they will absorb the moisture from the atmosphere. These are deliquescent in nature. Yes, no, no, no. What you can say, what you are telling? No, ma'am. Because it's cheap. See, your sodium hydroxides or potassium hydroxide, they are deliquescent in nature. That means they absorb moisture from the atmosphere and hence they become unsuitable for the reactions. Okay, they are not suitable for the reaction then. That's why we do not use them for the lab preparation. Also, the second reason is that your sodium hydroxide and potassium hydroxides are costlier than your calcium hydroxide. So they are costly than your calcium hydroxide. But the most important reason for this is deliquescency in the nature, because of which it is not suitable for the reaction. Clear all of you? Ankur, what you are telling? That not, no ma'am, because it is cheap. So is it clear all of you? Tell me fast. Is it clear to all of you in the session? Yes. Okay, so sodium hydroxide and potassium hydroxides both are deliquescent in nature. Okay, so please make a note of this. Okay. So because of this deliquescency, your calcium hydroxides are used, because calcium hydroxide is not deliquescent. This is basically not deliquescent. Also, it is cheap. Okay, it is cheap. Okay, ma'am, we want MCQs. Okay, Ankur, surely we will have the MCQs. Do not worry. Okay. So let's proceed now. Then again, your ammonium chloride and calcium hydroxide, they are taken in the ratio 2:3. That is, more ratio of ammonium chloride is taken. Sorry, just saying the ulta. Less ratio of ammonium chloride is taken. More ratio of calcium hydroxide is taken. Why this is so? Anyone can give the answer. Why this is so? Because your ammonium chloride is a substance which shows sublimation on heating. So if one of the reactants is getting decreased in the quantity, your rate of reaction can be affected. So to maintain the rate of reaction, to compensate for the loss of NH4Cl by sublimation, we are using more of calcium hydroxide, so that your reaction goes on and do not decrease, and the rate of reaction does not decrease. Clear? This is why you take more of your calcium hydroxide. Clear? Now, let's see the arrangement used for the lab preparation of ammonia. So, in this case, you can see you have this vessel in which we have kept your ammonium chloride and your calcium hydroxide in the ratio 2:3. We are heating this. So, what is happening? We have taken a pipe through it, which is going to a vessel which is again carrying lumps of calcium oxide. This is the lumps of calcium oxide, and from here again a pipe is taken to a vessel which is kept in the inverted form. Okay, which is kept in the inverted form. This is the entire arrangement for the preparation of ammonia. You can see over here that why we have kept, it is happening. Ammonia is formed, water vapor is formed, and calcium chloride is formed. So calcium chloride will stay inside the flask, and the vapors of ammonia mixed with water vapors will pass through this tube to enter into this vessel. Okay, this will enter into the vessel. Now we want the pure ammonia vapors. We do not want any water molecules to be mixed with it. Okay, we do not want any water molecules to get mixed with it. So what we will do? We will pass ammonia gas through your calcium oxide. Yes, through calcium oxide. Very good evening, SK. Okay, very good evening, Saurabh. Very good evening. Welcome to the session. So you will pass the ammonia gas through this calcium oxide, which is your quicklime, which is hygroscopic in nature. Okay, this is basically hygroscopic in nature, which will absorb all the water molecules present in the vapors of ammonia, absorb water molecules, or you can say moisture present in the vapors of ammonia. Just let me write that for you. Water molecules present in the vapors of ammonia. So to purify your ammonia, and hence only ammonia gas will pass through this pipe to enter into this vessel and will get collected. This is all about the preparation of ammonia. This is all about the arrangement of your ammonia preparation. Now, can you all tell me why the flask is kept tilted? Why the flask is tilted? Why is it not kept in the straight form? Because your water vapors, if it is kept in the straight form, water vapors will go above. It will stuck with the walls of the vessel, get converted to water, and will trickle back to the very heated flask. Yes? Yes, very good, Ankur. Absolutely correct. So to prevent the trickling back of water, okay? Prevent the trickling back of water. To prevent the trickling back of water into the heated flask. We are keeping the flask in the tilted form. Clear? Now, next question. Why calcium oxide is only used as a drying agent and not some other chemicals like concentrated sulfuric acid or phosphorus pentaoxide or your calcium chloride? These are also very good drying agents. So why we are using only quicklime or calcium oxide as a drying agent? So the reason for this is that calcium oxide is basic in nature and your ammonia gas is also basic in nature. So if you use calcium oxide to dry your ammonia gas, it will not react with your calcium oxide, but it will react with other compounds such as your sulfuric acid. Yes, absolutely correct, Ankur. Sulfuric acid and your phosphorus pentaoxide or calcium chloride. So that's why we do not use any other chemical to dry your ammonia gas or to remove the moisture from the ammonia gas. Next question is that collection of ammonia. Yes, yes. Collection of ammonia. How your ammonia gas is collected? Can anyone tell me? Yes, how is your ammonia gas collected? It is collected by downward displacement of air. Yes, this is collected by your downward displacement of air. That means air is displaced downward and your ammonia gas goes above inside the container. Clear? Now why this is happening? Why it is collected by downward displacement of air? Because ammonia is lighter than air. Very good, Ankit. So ammonia is basically lighter than air. Also, ammonia is highly soluble in water. That's why we do not prefer to collect your ammonia over water, because ammonia is highly soluble in water. Okay. So because of these two reasons, your ammonia is collected by downward displacement of air. Next question. Can we use some other salts instead of ammonium chloride? Can we use salts like ammonium nitrate instead of ammonium chloride in lab preparation of ammonia? Yes or no? And give reasons for your answer. What is the reason and what is the answer? क्या yes है या no है? Can we use ammonium nitrate instead of ammonium chloride in the preparation of ammonia? Okay. So it means the answer is no. Okay, no, we cannot use. Why? Because your ammonium nitrate, first of all, it is explosive in nature. ये कैसा होता है? ये एक्सप्लोसिव होता है नेचर में. ठीक है. और क्या होगा? अमोनियम नाइट्रेट इज सो अनस्टेबल, इट इज वेरी वेरी हाईली अनस्टेबल, that as soon as you heat the mixture, it will readily decompose to give you nitrous oxide and water vapor. So it will just like decompose and will escape in the atmosphere in the form of nitrous oxide and water vapor. It will not wait to react. It will not wait to react with calcium hydroxide to produce ammonia. Clear? It will not wait to react with calcium hydroxide to produce ammonia. It will readily decompose to give your nitrous oxide and your water vapor. So no, we cannot use it instead of NH4Cl for the preparation of ammonia. This is the first method of preparing ammonia from the ammonium chloride salt. Second method is preparation of ammonia from metal nitrites. ओके, फ्रॉम मेटल नाइट्राइड्स. मेटल नाइट्राइड्स कैसे इसको हम इसको कैसे प्रिपेयर करेंगे अमोनिया को. ओके, चलो. सो इन दिस केस मेटल नाइट्राइड्स में व्हाट वी आर टेकिंग, मैग्नीशियम नाइट्राइड वी आर टेकिंग एंड वी आर रिएक्टिंग इट विथ सम वार्म वाटर. ठीक है, वी आर टेकिंग योर वार्म वाटर, वी आर रिएक्टिंग इट टुगेदर. What happens whenever a metal nitride reacts with warm water? Your metal hydroxide is formed and along with that your ammonia is also formed. ठीक है, metal hydroxides and your ammonia both are formed. Clear? चलो. So in this case your ammonia is produced. Then aluminium nitride reacting with water. Which type of water? Warm water. So what will happen again? Your aluminium hydroxide will be formed and your ammonia gas will be formed. So in this way also you can prepare your ammonia. But we prefer your first method of preparation. Why? Because metal nitrides are generally costly. So this reaction, this method will be costlier than the first one. So we do not prefer this method. Clear all of you? This is all about your ma'am. Sorry. Okay, you're telling ma'am why only we use warm water. Okay, Ankur. Because see, magnesium nitride or aluminium nitride, these are not very reactive. So if you use like cold water, this will not initiate the reaction. So for that you need to give some temperature. That's why we are using your warm water. Clear everyone? Ankur, is it clear? Tell me fast. एंड अगर सेशन पसंद आ रहा है तो लाइक और शेयर करते चलना. ओके, प्लीज कीप लाइकिंग इट एंड शेयरिंग दिस सेशन विद योर फ्रेंड्स एज वेल so that maximum students can join the class. Okay, let's go to your preparation of aqueous ammonia now. ठीक है, preparation of aqueous ammonia. Okay, before going to the preparation of aqueous ammonia, let's talk about your okay. So let's, before preparation of aqueous ammonia, let's talk about the chemical properties of ammonia. And before chemical properties also, let's talk about your physical properties. Chalo. So we have seen the lab preparation of ammonia. We have seen, we will see now physical properties of ammonia. So tell me fast, what is the odor of ammonia? What is the taste of ammonia? What is the color of ammonia? What is the color of ammonia? What is the odor of ammonia? Now what is the taste of ammonia? Okay, all of these things you have to say. Chalo. Tell me fast everyone. Jaldi jaldi se batao. Right now you should be like promptly answering these questions. These are very very simple one. Absolutely correct. This is colorless. Odor, pungent, choking odor. Okay, it is having a pungent choking odor, that is smell. Taste, bitter, because it is basic in nature. And its nature, it's a basic gas. ठीक है, it is a basic gas. If you talk about its density, it is lighter than air. Okay, lighter than your air. If you talk about its solubility, so highly soluble in water. Okay, highly soluble in water. That is, the solubility is so high that 1 volume of water can dissolve 702 volume of ammonia. You can just imagine how high the solubility is. Your 1 volume of water is able to dissolve 702 volume of your ammonia. Yes, and to show this high solubility, we have a reaction called your fountain experiment. Sorry, not reaction. This is basically an experiment. So to demonstrate the high solubility of ammonia into water, we have an experiment called fountain experiment. Okay? We will discuss this experiment a little bit afterwards, after we discuss your chemical properties of ammonia. ठीक है, chemical properties of ammonia discuss कर लेते हैं. After that we will discuss your fountain experiment. So can you all tell me what are the chemical properties of ammonia? So first of all, let's talk about its thermal dissociation. Thermally, if you try to dissociate your ammonia molecules, what constituents or what products it will give off after the dissociation. So if you like subject your ammonia to very high temperature, ठीक है, very high temperature पे if you are subjecting it, it will produce your nitrogen gas and your hydrogen gas. Clear? So this is the first chemical property of ammonia. Then it shows all the basic properties. Okay, it shows all the basic properties only when it is present in aqueous form. Hello Himanshu, welcome to the session. Very good evening. Okay, but right now तो chemistry पढ़ लो पहले. After that we will think about the other subjects. Okay, चलो. So basic properties only when it is present in water. Okay, so it shows basic properties only when it is present in the water. In the gaseous state, it does not shows any basic properties. Am I clear, all of you? Ammonia can show the basic property when it is present in water. That means aqueous ammonia can show the basic property. ठीक है? Dry ammonia or liquefied ammonia gas cannot show the basic properties because of the absence of your OH minus ion. Clear? Third chemical property is your oxidation of ammonia. Oxidation of ammonia, or you can say burning of ammonia. ठीक है, burning of your ammonia in pure oxygen. So let me tell you, your ammonia is not a supporter of combustion. It is not a supporter of combustion, neither it burns itself in air. Okay, it is not a supporter of combustion, neither it is combustible itself. Okay, supporter of combustion. But if you like wants to burn ammonia, but your ammonia burns with a yellowish green flame. Okay, it burns with a yellowish green flame in presence of pure oxygen. So अगर pure oxygen है, if nothing, no impurities are present, if you are trying to burn your ammonia in the pure oxygen, it will burn with a yellowish green flame. Am I clear to all of you? Tell me fast. It will burn with a yellowish green flame in the presence of pure oxygen. So this will be termed as your simple oxidation of ammonia or burning of ammonia. ठीक है? This can be termed as simple oxidation of ammonia or your burning of ammonia. So अगर क्वेश्चन में कोई भी ऑक्सीडेशन ऑफ अमोनिया पूछता है या बर्निंग ऑफ अमोनिया पूछता है, you will write this reaction. Ammonia combining with pure oxygen to give nitrogen gas and water vapor. Clear? Ammonia combining with oxygen to produce nitrogen gas and water vapor. If you want to balance it, let's balance it to 3. Here also 4. 4 nahi, 2. So 2, here also we will have 2. Here also 3 to just 6, so 6. So already balanced. Clear? This is how you balance the chemical equations. So this is a very important reaction. All of you please understand this. Okay. This is simple oxidation of ammonia, and the observation for this reaction will be ammonia burns with a yellowish green flame producing water vapor and nitrogen gas. Clear? Fourth is your catalytic oxidation of ammonia. Okay, catalytic oxidation of ammonia. Am I clear? There is a difference between your simple oxidation of ammonia and catalytic oxidation of ammonia. Simple oxidation of ammonia में we are simply burning your ammonia in presence of pure oxygen. In catalytic oxidation of ammonia, hello आज तक weapon. Okay, so different names you have, all of you. चलो. So here in this case, your ammonia burns, reacts with oxygen in the presence of a catalyst, that is your platinum, at 800 degrees Celsius to produce your nitric oxide and water vapor along with the production of a lot of heat. Okay. Now this reaction won't stop here. ये reaction यहाँ तक ही नहीं रुकेगा. Further, in the presence of more oxygen, your nitric oxide will get oxidized to form your nitrogen dioxide, that is the evolution of reddish brown gas. Okay, reddish brown vapors. Clear? This is the entire catalytic oxidation of ammonia. Okay, Ankur, see what happens. Your simple oxidation of ammonia mein you simply take ammonia and burns it in presence of oxygen. Clear? In catalytic oxidation of ammonia, when this term comes catalytic, that means we are using some catalyst. ठीक है, use a catalyst. And what is that catalyst we are using here? This is your actually platinum. So ammonia reacts with oxygen in the presence of platinum at this much high temperature, that is 800 degrees Celsius, to produce nitric oxide and water vapor and your heat. Now this reaction won't stop here. Your nitric oxide, which is formed in the reaction, will further react with the oxygen to produce nitrogen dioxide, which is obtained as a reddish brown vapors. This is the catalytic oxidation of ammonia. Am I clear, Ankur? Tell me fast. क्लियर हो गया सभी को? At least tell yes or no ना. Okay, चलो, very good. So what are the observations we will have for this reaction? क्या क्या observations होंगे? Okay, observation first of all तो होगा कि एक reddish brown vapor evolve हो रहा है. Reddish brown vapors. Reddish brown vapors of nitrogen dioxide along with pungent smell is evolved. Okay, secondly, you will have platinum glows red even if external heating is removed. So platinum continues to glow red even if external heating is removed. Hello Priyanshi. I have a doubt about this, Priyanshi. So yes, there will be class 12 means classes for class 12. You can check it in the on this channel, Unacademy ICSE and ICSE YouTube channel pe. If you go on the page, you can check the classes if any classes are scheduled for your class 12. Okay? Yes. So yes, absolutely correct, Ankur. Platinum continues to glow red even if external heating is removed, which shows that the reaction is exothermic in nature. Okay, which shows that reaction is exothermic in nature. Am I clear to all of you? This is the fourth chemical properties of ammonia, that is the catalytic oxidation of ammonia. So please make sure you are very much clear about the difference between your simple oxidation of ammonia. This is your simple oxidation of ammonia, or you can say burning of ammonia, ठीक है, and catalytic oxidation of ammonia. Okay, okay, Vasu, okay, Vasu. Chalo. Clear? Now after this we will have your ammonia as a reducing agent. Fifth number is that ammonia is a very good reducing agent. Okay, ammonia is a good reducing agent. This is the fifth chemical property of ammonia. Now to showcase the reducing nature of ammonia, we have some reactions. Okay, to show the reducing nature of ammonia, we have particularly three reactions. Nature of ammonia, three reactions are there. Clear? So first is your reduction of metallic oxides, or you can simply write two reactions, because in under that only I will be giving you number of examples. Two reactions are there: reduction of metallic oxides. For example, if you take copper oxide and if you pass ammonia gas through this copper oxide, what happens? Your copper oxide will get reduced to copper, ammonia will get oxidized to form your nitrogen gas, and along with that your water is also formed. Clear? This is the reducing nature of ammonia, where it is reducing the metallic oxide, that is copper to copper oxide to copper. So initially it was black in color, now it has turned to your reddish brown solid. Okay, reddish brown solid. Clear? Now your nitrogen gas is evolved here. So the observation for this reaction is that black copper oxide is converted to or reduced to form your reddish brown copper. Clear? Okay, so here there has been a power cut, so you have to bear for some time. You will be able to see my hear my voice but not see my face. Chalo. Second is your reduction of lead monoxide in presence of ammonia. Okay? So let me show you this. In that case, your lead oxide will also get reduced to form lead. Nitrogen gas is produced. Along with that, your water is also produced. Yes, Ankur, I know. Chalo. So in that case, it was earlier yellow in color. Now it has formed your grayish colored metal. Okay, grayish solid. Am I clear? This is the observation for this reducing property of your ammonia. Clear? Next is your reduction of chlorine. So again, next reaction is reduction of chlorine. So reduction of chlorine, maybe we have two cases. If you are taking chlorine and reacting with ammonia, first case can be when you take excess of ammonia and less of your chlorine. In that case, your ammonia will form its own product. So what it will do? It will form nitrogen gas and NH4Cl. Clear? It will form nitrogen gas and your NH4Cl. So what is the observation for this reaction? I have already told you the observations. So your chlorine is a yellowish green color gas. It's a yellowish green gas. So yellowish green gas will get converted to form white dense fumes of ammonium chloride. White dense fumes. ठीक है? Got it everyone? Observations क्या होंगे? That your yellowish green color of chlorine will disappear and white dense fumes of ammonium chloride will appear. Clear? Yes or no बताते चलो in the comment section. Is it clear to all of you? And class को भी like करते चलो, okay? Because if you are really liking it, I want you all to please like this session and share it with your friends, so that maximum students can join us on this platform. Okay? Okay, so I hope it's clear. So chlorine is a yellowish green gas converted to your dense white fumes. Now the second case can be when you have chlorine reacting with ammonia, but chlorine is present in excess this time. So if chlorine is present in excess, this will form its own product. ये खुद का product form करेगा. What it will form? It will form your HCl and NCl3. Now again this was a yellowish green gas. ये कैसा था गैस? Yellowish green, है ना? और अब ये कैसा बन रहा है? यहाँ पर प्रोड्यूस हो रहा है येलो लिक्विड. ठीक है, येलो लिक्विड इज प्रोड्यूस्ड. So the yellowish green color of the gas will disappear and a yellow liquid is formed which is explosive in nature. This is the observation you will have for this particular reaction. Clear all of you? Yes or no? Tell me fast. Is it clear? Okay, these are the five chemical properties of ammonia. Now sixth chemical property of ammonia. Yes, absolutely correct, Ankur. NCl3 is explosive in nature. Okay. So sixth property of ammonia is reaction with acids. Okay, reaction with acids. So ammonia react with your acid, for example your HCl, to produce only salt. No water is produced. Clear? It is not necessary that whenever a base reacts with like acids, it will always form a salt and water. Sometimes your water cannot be formed because of the absence of your OH minus ions. Clear? Because of absence of OH minus ions, your water is not formed. Am I clear, everyone? Water is not formed. ठीक है? Similarly, if you take your ammonia and if you react it with H2SO4, it will produce ammonium sulfate and not your water, again because of the absence of your water. Sorry, absence of your OH minus ions. Clear? This is all about the chemical properties of your ammonia. ठीक है? Now let's talk about your fountain experiment. I told you after we will discuss the chemical properties of ammonia, we will discuss your fountain experiment. Fountain experiment is conducted to show the high solubility of ammonia into the water. Its main aim is to show high solubility of ammonia into the water. Am I clear, all of you? Understanding everything, understood everything? Please tell me fast to demonstrate the high solubility of ammonia into the water. What we do, we take a stand. Now after this we attach a inverted, okay. It also demonstrates that ki ammonia is basic in nature, but our main aim is to just demonstrate the high solubility of ammonia into water. We do not conduct this experiment to show the basic nature of ammonia. Clear, Ankur? So that's what I have written. This is the inverted flask which is containing your dry ammonia, and this flask is entirely filled with ammonia gas, totally packed with ammonia gas. ठीक है, dry ammonia gas. Now in the mouth of this flask we have attached a small dropper which is containing some water. It is containing some water, and then we have also attached a thin jet tube inside this flask whose one end is connected to this red litmus solution. One end is connected to this red litmus solution. Let me draw this red litmus solution. Okay, this is your red litmus solution. Clear? Now, what happens? Here you can see कि as soon as you squeeze the dropper, this dropper, if you squeeze it, what will happen? A few drops of water will enter inside the flask. Okay, few drops of water will enter inside the flask. As soon as the few drops of water will enter, these few drops of water will dissolve 97 to 98% of ammonia gas present inside the flask. And one thing you have to make sure that the mouth of this flask is totally covered so that no ammonia gas can escape through it. Clear? Yes. So here 97 to 98% of ammonia gas dissolves in the water. So as soon as it dissolves, your vacuum is created inside the flask. Vacuum, or you can say low pressure, is created inside the flask, because earlier the entire flask was completely filled with your dry ammonia gas. So as soon as maximum of ammonia gas is getting dissolved in the water, a region of low pressure is created inside the flask. Yes or no? Tell me fast. Vacuum is created in the flask. ठीक है. सो जैसे ही अंदर में लो प्रेशर का रीजन क्रिएट हुआ, व्हाट हैपेंस, द एटमॉस्फेरिक प्रेशर इज कंटिन्यूअसली एक्टिंग ऑन द सरफेस ऑफ दिस रेड लिटमस सॉल्यूशन. Okay, Jatinder. Day after tomorrow you have history exam, so please tell your team to make history subjects videos and not chemistry. Okay, I can understand your like concern, but right now we do not have any like sessions for your like SST subjects, so it is not possible right now. Okay, chalo. So atmospheric pressure is acting on the surface of this red litmus solution. So this will force the solution to enter inside this tube. Okay, this will force the solution to enter inside the tube. Understood? Yes. So जैसे ही enter करेगा inside the tube, as soon as it comes out in the form of blue litmus, sorry, blue color fountain. Okay, blue color fountain के form में ये बाहर आएगा. Why this is happening? Because the red litmus solution, okay, the red litmus solution contains your water molecules. Okay, contains your water molecules. Clear? Because of which, as soon as your ammonia comes in contact with the water molecules, thank you Ankur, thank you so much. Okay, so ammonia comes in contact with the water molecules present in your red litmus solution, present in red litmus solution. So as soon as ammonia comes in contact with water, it forms your ammonium hydroxide, which decomposes to produce your ammonium ion and your hydroxyl ion, and this is turning your red litmus to blue. Okay, turning red litmus to blue. Am I clear? So what is the main focus of this experiment? To show the high solubility of your ammonia into the water. Sorry, into the into the water, because 1 volume of water can dissolve your 702 volumes of ammonia. That's why when you squeeze the dropper and only a few droplets of water are coming inside the flask, that is able to dissolve your 97 to 98% of ammonia gas, because of which your vacuum is getting created. And as the vacuum is getting created, the red litmus solution rises through this thin capillary tube, and upon reaching inside the flask, whatever 2 to 3% of ammonia gas is left, that will dissolve in that red litmus solution and will turn the color of the solution to blue because of the production of OH minus ions as soon as ammonia comes in the contact with water present in the red litmus solution. Clear all of you? This is the fountain experiment. Any doubt anyone is having till here? So let's discuss about your aqueous ammonia. Okay, so aqueous ammonia is what? When you dissolve your ammonia gas into water, it produces your ammonium hydroxide, which in turn gets ionized. Okay, Ankur. Okay. Which gets ionized to produce your ammonium ion and hydroxyl ions. These OH minus ions are responsible for all the basic properties. Responsible for basic properties like, okay, like your turning red litmus to blue, red litmus paper to blue. Okay, am I clear? Then your methyl orange from from orange to yellow. ठीक है, these all indications, all the डाउट था पहले, अब सब उड़ गया. ओके अंकुर, थैंक यू सो मच. ओके आप, ओके चलो, वेरी गुड. So this is how your aqueous ammonia shows all the basic properties that is shown by a typical base, because upon coming in contact with the water, your ammonia forms ammonium hydroxide, which again gets dissociated to produce your OH minus ion, which is responsible for showcasing all the basic properties. So let's discuss your reaction of aqueous ammonia with acids. Reaction of aqueous ammonia with acids. So if your bases reacts with acids, they form salt and water. So aqueous ammonia is this, NH4OH. This is your aqueous ammonia. Clear? If they react with acids, for example HCl, they will form a salt, that is your NH4Cl, and your water. Here in this case your water is formed. That was not happening in the case of reaction between your ammonia and HCl, because here you have this OH minus ion, because of which the formation of water is possible. Clear everyone? So your ammonium hydroxides give normal reactions with all the acids, forming a salt, that is in this case ammonium sulfate will be formed, and your water will be formed. Clear? Yes or no? Tell me first. ठीक है? Now let's talk about your reaction of ammonium hydroxides with metal salts. ठीक है? Reaction of ammonium hydroxides with metal salts. So whenever your ammonium hydroxides react with some metal salts, so what is formed as the product? Your metal hydroxides are formed and your ammonium salt is formed. ठीक है? These two things are produced in the reaction. So whenever you react your metal salts with ammonium hydroxides, they produce metal hydroxide as precipitate, that is the insoluble solid present in the solution, along with the formation of a ammonium salt. Clear? Let me show you some reactions. For example, your iron sulfate reacts with your ammonium hydroxide to produce a metal hydroxide, that is your FeOH whole twice, and your ammonium salt, that is your ammonium sulfate, is produced. Clear all of you? Let me write this reaction properly. Just so this is happening. ठीक है? Ammonium sulfate. This is obtained as a green precipitate, not green, dirty green, basically dirty green precipitate, which is insoluble in excess of ammonium hydroxide. Okay, it is insoluble in excess of ammonium hydroxide. So then which is soluble in excess of ammonium hydroxide? Your zinc salts. Okay, for example zinc nitrate, if you take and if you react it with ammonium hydroxide, what will happen? Zinc hydroxide will be formed and ammonium nitrate will be formed. This zinc hydroxide will be obtained as white gelatinous, okay, white gelatinous precipitate, that is dirty white precipitate, which is soluble in excess of ammonia, which is soluble in excess of your ammonium hydroxide. This was asked in your sample question paper also, like which hydroxide, which metal hydroxide is soluble in excess of ammonium hydroxide. Okay, gelatinous. Clear? So basically zinc hydroxide is soluble and your copper hydroxide is also soluble. So when you take like copper sulfate and if you react it with ammonium hydroxide, it will form cupric hydroxide and ammonium sulfate. Now this cupric hydroxide is obtained as a pale blue precipitate which dissolves in excess of ammonium hydroxide to form a deep blue color solution. Okay, deep blue color solution. Am I clear? Tell me fast. So two metal hydroxides are soluble, that is your copper hydroxide and zinc hydroxide, in excess of ammonium hydroxide. This was asked in your sample question paper, that's why I discussed this thing. Is it clear to all of you? Tell me fast. Yes or no? Okay, चलो. Now what are the tests you have for ammonia? टेस्ट क्या क्या है अमोनिया के लिए? So let's have our tests for ammonia gas and ammonium ion. अमोनियम आयन और अमोनिया गैस के लिए क्या क्या टेस्ट है? सबसे पहला टेस्ट है इट्स पंजेंट ओडर. ठीक है, द कैरेक्टरिस्टिक स्मेल इट हैज. यस, वेरी गुड अंकुर, एब्सोल्युटली करेक्ट. Second test is that ammonia gas upon reacting with HCl produces the dense white fumes of ammonium chloride. So this is also a test for dense white fumes of ammonium chloride. That is also a test for your ammonia gas. Clear? And when your ammonia gas is passed through your copper sulfate solution, which was blue in color. ठीक है? So what happens? Your cupric hydroxide is formed and ammonium sulfate is formed. Let me write it clearly for you. Cupric hydroxide is formed and ammonium sulfate is formed. So this is a pale blue color precipitate which dissolves upon passing. This dissolves upon passing excess of ammonia gas. Clear? This test is also for your aqueous ammonia. This is a test for your aqueous ammonia as well. Clear all of you? Understood this much? Should I remove it? Now one more test is there, that is your Nessler's reagent. Okay, Nessler's reagent. What is this Nessler's reagent? This is your K2HgI4. This is the potassium mercurate, alkaline solution of potassium mercuric iodide. Potassium mercuric iodide. ठीक है? So as you pass ammonia gas through it or ammonium salt through it or whatever you do, okay, pass ammonia gas through this Nessler's reagent, it will change the color of Nessler's reagent from colorless to brown. So what will happen? Nessler's reagent will become brown in color. Am I clear to all of you? Understood? Yes or no? Tell me fast. ठीक है, earlier your Nessler's reagent was colorless. Now it has changed its color to your brown in color upon passing your ammonia gas or dissolving your ammonium salts into it. अगर आप ammonium salts dissolve करोगे, you will obtain a brown color precipitate. Clear? These are the different tests used for the detection of your ammonia gas or ammonium ion. Am I clear to everyone? Tell me fast. Is it clear to everyone in the session? And please keep liking the session if you are really liking it. ठीक है? This is all about your ammonia. Okay, this is all from the chapter of ammonia. So we are left with your industrial preparation of ammonia, that is your Haber's process, and preparation of aqueous ammonia. These two things are left out. Okay? No, chapter khatam kahan hua Ankur? Haber's process is left. No, Haber's process and your preparation of aqueous ammonia. These things are left out. which we will discuss. प्रिपरेशन ऑफ एक्वस अमोनिया डिस्कस कर लेते हैं. ओके चलो. Preparation of aqueous ammonia. So what happens? You can prepare your aqueous ammonia by dissolving your ammonia into water. You can take water and you can dissolve your ammonia gas into water to prepare the aqueous ammonia. Dissolve ammonia into water to prepare aqueous ammonia. Am I clear, all of you? So this thing we will discuss in detail in next class. ठीक है? We will discuss this in detail in next class because the time is getting over. So if I will start this part, this will not be completed. Okay, so I will discuss it in the next class when we will discuss your Haber's process and your like this preparation of aqueous ammonia. Along with them, we will also discuss some important MCQs from all the 4 topics, that is your study of compounds. Clear, everyone? So I am removing it. Okay. So before I end the session, let me tell you about the Emerge test series. This is for your class 10 learners. You can, class 10 and 12 learners as well. You can like enroll yourself for this test series using my code Manisha Live. Okay. Yes, sure, Ankur. Do not worry. I will discuss the Haber's process and your preparation of aqueous ammonia before your exams. Do not worry. Okay, so Manisha Live is the code you will be using to enroll yourself for this free test series. Okay, these are all free test series. You will obtain 100% scholarships if you are getting good marks. Okay, so we have a challengers batch started for class 9 students already. No, sorry, tomorrow it is starting from tomorrow, class 9 के लिए. So you can enroll in this batch. Also for class 10 new learners, we are starting Apollo batch from tomorrow itself. You can enroll yourself also for this batch. And for class 10 learners, to prepare you all for the term 2 examinations, we are already having a challengers batch. So you can enroll yourself for that batch also. Okay, by taking the subscription. Yes, sure, Ankur. We will have the MCQs for all the chapters. Do not worry. So we have communities for every educator on Unacademy app where you can like get the updates from your educators, session notes and practice material, feedback you can share with your educators. So the link of the educator community is given in the description from where you can join this community. Again, there is a feature called Bugs Bounty. So if you see any like inappropriate content in the video, you can report that to the Unacademy team. If you are the first one to report such a inappropriate content, you will be able to receive the prize. How can you report it? There is a form given in the description. Using that form, you can report any inappropriate content if it is present in any of the videos. So thank you all. That's for today's session. So this is so we will stop here only. So do not forget to subscribe to the channel and hit the bell icon, because so that you never miss any updates from the channel whenever I go live. And you can download the notes of this class from the Telegram channel, the link of which I have provided in the beginning of this session. So thank you everyone. Bye bye. Take care. Keep studying hard and all the best for your next history examination. So bye. Let's meet again tomorrow at 9 p.m. Okay.